Structural engineering is a subdiscipline of civil engineering in which civil engineers are trained to design the bones and muscles that create the form and shape of man-made structures. Prerequisites of structural engineering. For pursuing masters in structural engineering, one must have good grip on the following subjects during Bachelor of Civil Engineering: engineering mechanics, strength of material, mechanics of solids, structural analysis, concrete structure, pressed rest concrete structures, design of steel structures, CAD in structures. Subjects for masters in structural engineering: theory of elasticity and plasticity, analysis of the stresses and strains for two-dimensional and three-dimensional elements, study of equilibrium and compatibility conditions, numerical on torsion for different shaped bars. Understand the concept of plasticity. These are the reference books. Design of concrete structural systems, analysis and design of deep beams, design of shears wall buildings and flat slabs, design of slender columns. These are the reference books. Structural dynamics, study of behavior of structures subjected to dynamic loads such as wind, earthquake, and blast loads. Study of different dynamic analysis procedures for calculating the response of structures. These are the reference books. Finite element analysis, fundamental concepts of the theory of the finite element method, introduction of basic aspects of finite element technology, including domain discretization, polynomial interpolation, application of boundary conditions, assembly of global arrays, and solution of the resulting algebraic systems. Study of basic finite elements for structural applications using truss, beam, frame, and plane elements. Application of finite element software to solve engineering problems. These are the reference books. Advanced design of steel structures, analysis and design of various components in steel structures under different loads. Study of behavior of different connections in steel structures. Numericals of wind load analysis and plastic analysis. Study behavior of different members. Design of structural members and their connections. These are the reference books. Matrix methods of structural analysis. Basic concepts of matrix methods of structural analysis. Numericals of different structures by using flexibility and stiffness methods. Analysis of substructures, frames, and trusses. These are the reference books. Machine foundation. Basics of principles of soil dynamics. Study of mathematical models and DOF. Study the concepts of stiffness, damping, inertia, guidelines for design. Conducting dynamic analysis and design of machine foundation. These are the reference books. Stability of structures. Study of stability of structures. Study of stability of plates and shells. Comparison of stability and instability. Evaluation of the structural stability of columns, frames. These are the reference books. Repair and rehabilitation of structures. Introduction of repair and rehabilitation of structures. Study of rehabilitation methodology adopted for various structural systems. Study of properties of fresh and hardened concrete. Strategies of maintenance and repair. Study of properties of repair materials. These are the reference books. Earthquake-resistant design. Study of basic concepts of engineering seismology, strength, and capacity design principles of earthquake-resistant design. Study of various types of buildings under static and dynamic forces subjected to earthquakes. Study of basic concepts of earthquake engineering and principles of earthquake-resistant design. Analysis and design of various types of structures under static and dynamic loading conditions. These are the reference books. Theory and design of plates and shells. Study the behavior of plates and shells subjected to various loading. Study the analysis and design procedures for plates and shells. Analysis of the plates and shells of various shapes and properties. These are the reference books. Elective subjects. Design of bridges. Advanced concrete technology. Advanced foundation design. Numerical modeling in structural engineering. Analysis and design of tall structures. Some of the roles and responsibilities of structural engineer. Analyzing blueprints, reports, maps, geological and topographical data. Preparing designs, reports, and drawings. Providing technical advice on compliant designs and construction. Obtaining approvals for planning, design, and regulation of buildings. Analyzing structure components and configurations. Inspecting and monitoring the work of contractors to ensure structural integrity is maintained. Use computer-aided design technology for simulation purposes.